Okay, so I'm going to go through and do your quiz problems. This will also be a decent test review because this quiz covered 8.1, 8.2, 9.1, and 9.2. So it's about half of your test or more, a little more maybe. So the question is, a lot of times is when do you use which formula, right? So if I look at my, so here's your formula sheet. So let me run through this real quick. And I just posted this on Canvas, if I'm asking you probability questions, we're going to use the same approach we did before we went online, and that was calculate a z-score and then look up your probability in your chart. The new thing is we have different z-scores, right? We have our regular old z-score formula, x minus mu over sigma. And then when we're talking about sampling distributions of the means, we have our data is the mean. So we have what's the probability of seeing some kind of sample mean, right? So we have x bar minus the population mean. And we divide by this sigma over root n. And then, so I have to look for those in the problem, right? What's the probability that the sample mean, that means this formula. Right? Likewise, what's the probability that the sample proportion is greater than 0.71? I would think I have to be thinking this z-score formula, right? Because we know that these are normally distributed with certain conditions. Okay, so any probability question, we're going to be looking at these guys. When I ask you to do a confidence interval, chapter 9, then I'm really only asking you to do those by hand or to show me work for proportions, right? Because they follow that normal. So the confidence interval, we add, this is what I'm going to give you, that margin of error, we add that, some z in your book, it was z alpha over 2 times your standard deviation, right? So if I ask for a confidence interval for proportions, you should be thinking about this stuff. And typically it's a 90, 95, or 99. I won't make you look up any of those. I think I did that once in your homework, but I'll give you those, okay? And then that's it. Everything else going forward, I'm going to let you use the computer. Confidence interval for means isn't on here. That's the t distribution. I'm just going to let you use the computer for that. And then once we're into hypothesis testing now, you're always going to be doing that by StatCrunch. Make sure you watch my videos on that one. Okay, so that's the reviews. Let's look at your quiz. And the first question goes like this. Current approval rating is 0.42. So, I mean, when you look through these problems, you should be thinking, okay, what is that? That's a proportion. Is that a p or a p hat? Well, that's a p, right? We believe that to be the proportion, even though you could argue maybe it's some kind of sample. But what we're saying is that's the perceived proportion. And we're going to take a sample of 500 people and see what the probability that over 225 approve. So I want the probability that p hat is greater than 225. We could calculate that if we want. We just go to decimals. 225 out of 500. Okay. So what is that, 0.45, I believe? So the probability that p, so this is just similar to those z-score probability questions we did before. So we just need a z-score that goes with that, right? So I need the probability that z is greater than something, and that z should be given by this formula, p hat minus p over p, q, n. Oh, I know what I want to tell you about the formulas. Let's go back to those real quick. So notice in this example, we have p. We know what p is. We know what the population, we have some idea of what the population proportion is. But when you do confidence intervals, this standard deviation shows up a couple times, right? So let's jump to your formula sheet. When I'm doing this probability, I know what p is, right? I know, or at least I think I know what the population proportion is. So that's what I'm going to put in my standard deviation formula. But you'll notice down here, this is, again, the same standard deviation formula, only there's p hats and q hats in there instead of p's and q's. Why is that? Well, when you're doing a confidence interval, you're estimating the population proportion, so you don't know what it is. So the only thing you can do is use the given sample data when you're using the standard deviation formula for confidence intervals. Okay. So in other words, if you have a p, if you're given p, use it. If you're not, well, you can't use it because you don't have it, so you have to do your best with p hat. Okay, so I hope that makes sense. So, I mean, it'll always be the case for probability. For this type of question, I'll be given p. All right, so what I have to do is calculate my z-score and then go to my formula sheet, right? So, I'm sorry, go to my z-score sheet is what I should be saying. So 225. So I would have to, so the z-score then is 0.45 minus 0.42 divided by the square root of p 0.42. Q is 1 minus 0.42, so that should be 0.58, all divided by the 500. Okay, that is my z-score. So I go 0.42 times 0.58 divided by 500 square root. So I end up with something like this for my z-score. The numerator is 0.03, the denominator is 0.022072, something like that. So 0.03. So my z-score is about 1.36. Okay, and I'll leave the looking that up to you. The answer should have been, where is it? I believe about 8.0871, I think was the right answer, 0.0871. Okay, so once we get to z, it's all the same as what we did before. Look it up on your chart. Okay, next question. Same idea, only we're talking about means. Okay, it is known that women over 60 have a mean population mean. So start identifying stuff. That's mu. Standard deviation, that's sigma. Local doctor has 45 patients, that's n. Probability, that means I should be calculating a z-score and then looking up the probability from my chart. So I go to my formula, say I say z-score for the means, it's got to be this guy. Right, so for this problem, it's x bar minus mu. So I need a z-score. So the z-score is x bar minus mu over sigma over the square root of n. Start filling in the blanks, right? Mu is 52. We want the probability that the patient's got under 56. So we'll do the under part in a minute. 15 over the square root of the total number of patients, 45. So that's going to be equal to 4 divided by 15 over root 45 as to give me a z-score of, let's see, 15 divided by root 45. Maybe I calculate that first. 2.23 on the bottom. So 4 divided by the answer, and I get 1.788, 1.789. That's my z-score. So the probability that x bar, probability that the patients is under 56 is less than 56. We converted it to standard normal like we always do for these probability questions. So that's got to be z less than 1.789. That should be pretty big because if I drew a picture of that, there is your mean and the z-score. Remember, 2 is pretty high, so this answer is all that, which should be 0.9632. If you look that up, 0.9632, see if you can find that guy, or somewhere close to there. I'm not too picky about rounding. If you did some rounding here, then this number, or you did some rounding here, this number might be a little different, and you might end up with a slightly different number there. But it shouldn't be off by like 2 percentage points or anything like that. 1 at the most, but really not off by more than 1%. Okay, moving along. We sampled, question 3. We sampled 500 people and asked if they approved how the president's handling the current situation. 203 said they approved. 95% confidence interval for the proportion. Okay, so I should be thinking, all right, I'm going to have to build this thing. It's the one thing I'm going to make. Confidence intervals, you're going to have to do 2. 1 for proportions, 1 for means. For proportions, I'll make you do the work. And you got the formula for that. All right, so we're going to use this formula. For means, I'll let you do StatCrunch. Okay, so here is my answer. So let's see, 203. So I can do my point estimate, or my p hat. 203 out of 500 is 0.406. Okay, and then all I have to do, remember, the idea of confidence interval isn't terrible. I'm just going to add a number to that, subtract a number for that. That 0.406 is going to be right in the middle. Okay, and that's going to be my confidence interval. So what number am I going to add to that? Well, it's this margin of error. So it's going to be 95% confidence. So I would go to my formula sheet, and we know that that's about 2 standard deviations away. We used to call it 2, then we got a little bit better. Now it's 1.96. So it's my z value there. So here's your formula. And then times standard deviation, right? And the best we can do is estimate it with that formula. So it's going to be 1.96 times 0.406 times 1 minus 0.406, which should be just a little 0.594. I think I did that right. So if it's 0.4, that's 0.6. And then divide that by your sample size, which was not 203, but 500. So let's see what I'm going to add to this. I got 0.406 times 1 minus 0.406. 0.594 divided by 500. The square root of that. Sorry. I get 0.021. I got to multiply that by 1.96 for my margin of error. 0.043. This is about 0.043. Right? So my answer then is the center of my estimate plus 0.043, and then the center of my estimate, or my point estimate, minus 0.043. And again, you might get something a little bit different based on how you rounded. But you should be close, shouldn't be that far off. And that gives me a 95% confidence interval based on that number, is 95%. About 0.36, depending on how you round. You're somewhere around 0.36 to about 0.45. Yeah, it looks about right if you rounded 2 decimal places. Okay. We are 95% confident that So here's how you interpret that. We are 95% confident that the population proportion, never hurts to put that word in there. A lot of you give me the proportion. That's fine, right? That's really what I'm asking for in the question. That's how I word it. Construct a 90% confidence interval for the proportion. It's really the population proportion, right? We're using sample proportion to tell us something about the population. We're 95% confident that the population proportion of Americans that approve of how the president is handling is that spelled right? That looks weird. Handling the current COVID-19 situation is between 0.36 and 0.45. Okay. I know that's kind of a cookie cutter answer, but I mean, that's good for you. Hopefully it makes sense what a confidence interval is. It's good for your grade because you really can just kind of memorize that wording, right? And it's going to be the same in the next one too. On the next one, I'll let you use StatCrunch. So let's see how you're doing with that. So we'll start talking about conditions. When we get into the hypothesis test, I'm going to make you do the conditions for every test. And it's the same distribution, so the conditions are really the same. So when I ask you to do a hypothesis test to compare some kind of mean, I'm going to say, what's conditions? It's going to be the same as this one. And that is for the t distribution now, we need a simple random sample. Let's see if it told us that, or estimate the mean. Sample 35 randomly selected. Yep, simple random sample, check. And then B, two things have to happen here.